All right, another way to find the slope of a line, down in blue. If I have an equation of a line, and we said, well, I could find the slope of this line if I had 2 points on my line. So algebraically, I know how to find some points on my line. I could find the intercepts. If I wanted to find the x-intercept, I could set y equal to 0 and get x equals 6. I'm skipping some steps for those of you who like to see them. I could plug in x equals 0 to find the y-intercept. And then I could say, well, now that I have 2 points, I could take y2 minus y1 over x2 minus x1. And then I could reduce that to lowest terms and find out the slope of this line is negative 2/3. That tells me that my line falls as I read it from left to right, if it has a negative slope. There is also another way, if I have the equation of a line, that allows me to find the slope without going through all of the process. And there's nothing magic about those 2 points. I could plug in x equals 1 and x equals 2 and use those 2 points to find the slope. I would still find out that's equal to negative 2/3. Okay. The other way is to put the equation of the line in what's called slope-intercept form. We call it slope-intercept form because when we have the equation written in this form, we can see what the slope is and know the y-intercept. If I take this equation here and rearrange it so that the y is by itself, something we did earlier in this chapter or the one before, then the number in front of the x, the coefficient, this m is the same m that we defined earlier on as the rise over the run. Okay, the b here is the y-intercept of this line. This equation here, 2x plus 3y equals 12, is written in what's called standard form. And if I want to get from standard form to slope-intercept form, there's 2 steps. Okay, the first one is to add or subtract the x to the other side to get it away from the y. The next step is to divide by that coefficient, so divide by the 3. Okay, third step, I guess, you could say 3 steps, is simplify. I can split this apart. I have negative 2 over 3 times x plus 12 over 3 is 4. Now the number, once I'm in this form, the number that's multiplied times the x is, okay, that's the slope of my line, negative 2/3, which notice is the same thing I found when I found my 2 points and used the slope formula from the last video. Okay. Also notice right here, my plus 4, this is supposed to represent the y-intercept, which while I did the work very quickly, for some, notice that's what we got for our y-intercept. There it is, 0, 4. Something very nice about slope-intercept form is that, hands I can use here and click. If I want to draw a graph of a line, if I want to sketch a graph of the line 2x plus 3y equals 12, slope-intercept form of this line gives me all the information that I need to draw a picture of this line. Okay. If I know a point on my graph and I know the slope, that's enough information for me to draw a picture of that line. I know it goes through the point 0, 4. I labeled that in a bad place. It's okay. If I know that the slope is negative 2/3, and I know that the slope represents the rise over the run, if I'm going to rise negative 2, that means I'm going to go 2 steps down. Negative direction is down. If I'm going to run positive 3, that's 3 steps to the right. If I go down 2 steps from 4, I'm at 2. If I go to the right 3 steps from 0, I'm at 3. When you graph a line for me on your homework quiz or test, I need to see at least 3 points plotted and labeled. So at least 3 dots on your page, and all of them with their addresses labeled. Now notice the number negative 2/3. I had the negative sign with a 2 up here in my equation, but instead of putting it with a 2, I could think of it as being with a 3, which means from the point 0, 4, I could have gone up 2, rise of 2, and left 3 right here, which is negative 3, 6. I'm going to label that. And notice that's still in line with the other dots that I have up there already. So I can find the slope from slope-intercept form instead of finding slope with 2 points if I want to. And here's one example of a graph. I'm going to have another video specifically on graphing that has more examples there if you need more.